Welcome to this exercise on calculating extrema for functions with just one variable. Here we have simple function 2x to the power of 3 minus 6 times x squared plus 8, and we're asked to calculate all extrema of the following function. If we go about this, the first step is actually calculating first and second derivatives. So for the first derivative, we take a look at this. The 2 we copy as is, and then we take the derivative of x to the power of 3. So the 3 gets in front, the exponent is reduced by 1. So we have 3x squared times the 2 from before, giving us 6x squared. Here we do the same as well, copy the minus 6 down here, take the derivative of x squared, which is 2x. So minus 6 times 2x gives minus 12x. The 8 is a constant, so the derivative is 0. Well, so much for the first derivative. For the second derivative, I copy the 6, take the derivative of x squared, which is 2x. So 6 times 2x is 12x. And for the second part, I copy the minus 12. The derivative of x is 1, so that's my second derivative. So far so good for the preparation work. Now I need to get the possible extrema, or the extreme positions, and I get this by getting or applying my necessary condition, which is that the first derivative needs to be equal to 0. So I'm going to set this equal to 0 and then solve for x. Well, here I can see that both of the two terms have an x, so I can factor out the x, writing it like this. This shows me if this expression should be equal to 0, either the x needs to be 0 or whatever is here in the parentheses. So I found my first possible extremum, which is x being equal to 0. That's the first one. And then the remainder I need to take a look at is this part in here and consider when this gets positive 0. So I set this equal to 0, solve it for x, so I go with plus 12, having 6x equal to 12, divide by 6, and I get as a solution x equal to 2. So I have two possible extrema, one at 0 and one at 2. And now I'm going to use the second derivative in my other condition to check whether they are actually extrema or saddle points, and if there are extrema, which kind of extremum do I have, minima or maximum. Well, I'm using the sufficient condition by inserting first 0 into the second derivative. Then I get a value of minus 12 because the first term I have times 0 becomes 0. Well, end result minus 12. This is negative. And if I get a negative value for the second derivative, this shows me that at this position I have a maximum. Well, so far so good. Continue with the next one with x equal to 2. Again, I'm going to insert this into my second derivative. Here I get 24 minus 12, so 12 as a result. This is positive. Positive second derivative tells me I have a minimum. So summarizing, I have a maximum at 0 and a minimum at 2. So two extrema for my function which I considered. Well, that's then already everything there is to this exercise. So I say goodbye and see you next time.